Hello students, welcome back. So in today's video, let us take a look of the chapter called as Structure of Atom. Since the childhood, we have been studying about this atom. So here, the earlier theories which explained regarding the structure of atom was given by one of the famous scientists called as John Dalton. Now, according to John Dalton, the structure of atom is such that it cannot be subdivided. So that was the major drawback, because earlier this theory had existed, but later on so many experiments were done and subatomic particles were identified. Hence, John Dalton's theory of atomic theory could not explain about the subatomic particles. For several years, it was understood that atom is indivisible. But later on, he could not explain regarding that the subatomic particles. Hence, this theory came to an end. Then, how these subatomic particles were introduced? During the experiment, which was done by several scientists, among those, Michael Faraday had begun the study about the electric discharge in the cathode ray discharge tube. So during this discharge tube experiment, it was seen that whenever an electricity is passed through a discharge tube and it is connected by means of a high voltage battery, and an evacuated tube is taken and it is filled with a neutral gas, and once this circuit is completed, it is seen that a stream of particles were moving. So if this is the cathode and this is the anode, it is seen that there are several charged particles moving towards the anode, means moving towards the positive electrode. So there was a conclusion that if the particles are moving towards the anode, that is towards the positive terminal, means these particles should be what? It should be negatively charged. Hence, there was a conclusion arrived that the particles which were moving towards the anode have negative charge. They called it as the cathode rays, and the stream of the particles is nothing but it is the electrons. So in this way, the electrons were discovered. But precisely the name electron was given by Sir J. Thomson. Now, when these particles are moving towards the anode, what are the characteristics of this cathode rays then? So the rays which are traveling towards the cathode were called as cathode rays, and they started from cathode and they moved towards the anode, and these moved in a straight line, and they were not visible by themselves, but this could be seen by making use of a fluorescent metal or a fluorescent plate on which these particles struck. So when these particles struck, then it could be seen some bright spots were seen, indicating that some particles are striking. So therefore, there was an fluorescent material used over here towards the anode. In presence of this magnetic field and electric field, the cathode rays showed that they are having the negative charge. But in the absence of electric and magnetic field, they travel in the straight line. And these electrons or the cathode rays does not depend upon the nature of the gas. Irrespective of whichever gas is taken in this cathode ray discharge tube, in this one you take any gas, these rays were passing from cathode to anode. So it is irrespective of whichever the gas might be there. So after discovering this electron by J.J. Thomson, in the same experiment itself, when there was movement of the electrons or the cathode rays towards the anode, it was assumed that if there is some particle in which there is negative charge, then there should also be something to neutralize that negative charge. So it was thought that there must be some positive particle as well. So to find out this one, in between a perforated substance was used here. A perforated cathode was used. Now what is done is, some of these particles were moving from cathode to anode. But it was seen that some of these particles also moved in the opposite direction. Instead of moving towards the anode, they started moving towards the cathode also. Now suppose if you take hydrogen in this gas tube. So if you are taking hydrogen and due to the electric discharge, if the electron is coming out of this hydrogen atom, then if the electron is moving towards the anode, the remaining thing is nothing but it should be H plus. Now this H plus, what happened? This came behind side. It came towards the cathode. Instead of going towards the anode, the remaining left out came towards what? Towards the cathode. So this indicated that there must be something positive also which was existing along with this negative charge. And this led for the introduction of the proton. But actually Rutherford found that these protons were present in the nucleus. So ultimately Rutherford got this credit of finding the proton. Though other scientists had seen that there are certain positive charges moving towards the cathode, but still the name proton was coined by Rutherford. Hence, these two particles, that is electron and proton, were introduced. Also, J.J. Thomson introduced this experiment to find out the charge to mass ratio of the electron. When he took a electric discharge tube in which we have a cathode and an anode, and when the ray of light is treated in presence of the magnetic field and the electric field which is perpendicular to each other, it is seen that whatever the electric discharge is going to take place, it is going to go and hit this point B. Suppose only if the electric field is applied, then it will go to one point. Only if magnetic field is applied, it goes to another point. In presence of both of these fields, it will go to a certain particular point. Based on this, J.J. Thomson, he gave the mass, the charge to mass ratio, and the charge to mass ratio of an electron was found out to be as E divided by M is equal to 1.75882 into 10 raised to 11 coulomb per kg. So by carrying out these experiment, he was able to give the charge to the mass ratio. After finding the charge to mass ratio, further it was easier for him to give what is the absolute charge on the electron. So later on, by doing several experiments like Millikan's oil drop experiment, it was found that the absolute charge for the electron is minus 1.6022 into 10 raised to minus 19 coulomb. So after knowing the charge to mass ratio and after knowing the charge of the electron, the mass of the electron was easily found. Hence, from J.J. Thomson's experiment, after finding the charge to mass ratio and after finding the absolute charge on the electron, the mass of the electron would be the ratio of charge divided by charge to mass ratio, which you will get it as 9.109 into 10 raised to minus 31 kg. So this is the mass of the electron. In the same way, the relative charge means with comparison when you are going to do. So the relative charge for an electron was considered to be as minus 1. Remember, absolute charge is minus 1.602 to 10 raised to minus 19 coulomb. But relative charge means with respect to the positive charge and the neutron, this was considered as negative charge, minus 1 charge. Then, as the proton was discovered, as I told you, these electrons were moving towards the anode. In the same way, the positively charged species were moving towards the cathode. Based on that, the proton was discovered. And these rays were called as the canal rays, which were exactly opposite to the cathode rays. Now, canal rays, they are positively charged gaseous atom which depend upon the nature of the gas in the cathode ray. For electrons, when we found out, it was seen that it is irrespective of whichever the gas is taken. But these canal rays, which is opposite to the cathode rays, they depend upon the nature of the gas. And the charge to mass ratio of these rays depend upon the gas from which they had originated. So therefore, it depends upon the nature of this gas which is used in the cathode ray tube. Then, the behavior of these particles in the magnetic field and electric field is exactly opposite to that of the electrons. Hence, it is seen that these positively charged species were named as proton and those rays were called as the canal rays. Then, what is the charge of the proton? The charge that is called as the absolute charge is plus 1.6022 into 10 raised to minus 19 coulomb, and mass of the proton comes out to be 1.67262 into 10 raised to minus 27 kg. But relative charge means with comparison with that of the electron, you can take relative charge of the proton to be as what? As plus 1. In the same way, after experiencing negative charge and positive charge, it was expected that there should be something present in the atom which must be even neutral. Hence, neutron was discovered. This neutron was discovered when a very thin sheet of beryllium was bombarded by alpha particle and electrically neutral particles were emitted and these were named as neutron. So James Chadwick got the credit for inventing neutron, whose charge is relatively zero, absolute charge and relative charge were 0. Then, after doing all these things, there was a question then, what is the structure of atom? So earlier, Thomson suggested one model of the atom after knowing that there must be a positive charge, there must be a negative charge and there must be some neutral charge. So Thomson proposed one of the model which is called as Thompson's model of the atom. It was also called as the watermelon model or the pudding model, plum pudding model. Now maybe at that time Thomson was eating a plum pudding, which is nothing but a cake which has some dry fruits in it. So when somebody asked him what is the model of the atom, as he had discovered about the electron, so he must be knowing something about the atom. So when people asked him, must be he had that plum pudding in his hand, and it struck for him that the model of the atom is something like a plum pudding, or just like a cake, or it might be just like a watermelon. So how this watermelon then? Now watermelon means what? It is seen that you have the outer covering, that is something like green color outside, that entire layer. So that was considered to be as what? As the neutral particles. And whatever the red color of the watermelon is there, that was considered to be as the positive charge, which is distributed throughout the watermelon. So in that way the positive charge must be there, and in that positively charged red color there are certain seeds in it. So those seeds were considered like the electrons. So the electrons or the seeds were submerged entirely in that ocean of that red color positively charged species. So this is what was given by Thompson's model of an atom. So according to Thomson, the entire mass of the atom is evenly distributed. But meanwhile, Rutherford was also doing certain experiment. Now this Rutherford was not trying to find something regarding the atom or charged particle. He was just doing an experiment regarding the alpha rays, how to protect these alpha rays from spreading. So that time what he did is, Rutherford, he took one small thin piece of gold foil and he bombarded it by means of alpha particle. Now what he did is, here he took a gold foil and this was enclosed, and here he took the source of the alpha particles. Now he was looking for the study of these alpha particles. So he wanted to study that one. So what he did, how this alpha particle is going to interact with the gold. So for that reason he used this experiment. Now in this alpha ray scattering experiment, when the alpha rays were emitted through a small slit, here when the rays alpha particles hit this gold foil, gold thin sheet of gold foil, foil means thin sheet. So that time what happened, it should have seen that all these alpha particles should hit that foil and it should go directly undeflected, or it has to show a similar pattern, but it is not seen. Then if structure of atom is uniformly distributed, whatever the particle hit this gold foil, the atoms present in the gold also should behave in the same way. So all those rays whatever hit the gold foil, that is the atom, it should have gone in the same direction. But Rutherford found that some of these rays deflected to a smaller angle, some of the rays went undeflected, some of the rays got deflected in the opposite direction. So this led Rutherford to think why like this it is happening when the alpha ray is same, gold foil is same, but why there is difference in the deflection. This was seen based on the screen behind which was used, that is zinc sulfide material was used, which is a fluorescent material. So if anything strikes here, there will be some glow. So it is seen that the glowing particle is here, here, here and in the opposite direction. Now this led Rutherford to think that Not necessary the structure of atom should be like how Thomson suggested, like a watermelon, where the mass is entirely distributed, and there must be an electron which is submerged in the positive. Then what made him think? He said that there must be certain mass which is present in the center, which was called as the nucleus. Now, when the alpha particle is coming and hitting this nucleus, which is dense, that time what happens? Because it is dense, this ray of light, instead of passing, it got deflected behind. So there must be something in the center which is quite dense, which was called as nucleus. Then some of these particles which were there, they hit just side of that nucleus, that is the central portion, and hence they deflected to a smaller angle. Whereas some of the rays went just beside this nucleus, which was there at the center. So this space was empty. Therefore, what happened? The particles which passed from here went undeflected. So they went and hit over here. So the undeflected part means what? It has gone from the path where there is nothing. Means there must be empty space. Too much of empty space must be there in that atom when compared to the smaller mass, that is the smaller nucleus present in the center of the atom. So this is what Rutherford's model of the atom consisted of. So according to him, what he told, there must be centrally placed nucleus whose size is very small but it is dense, and there must be certain negatively charged which are moving around, and there is a lot of space in between, and hence there the particles have gone through it without deflection. So this led for the Rutherford's model of the atom. So according to the Rutherford, then how was the structure of atom? He said that there must be some positively charged species present in the center along with the neutral species. Together they have formed a thick mass at the center, but it's a very small region compared to the entire dimension. So this is about the nucleus present, and the nucleus is surrounded by the electrons that move around the nucleus with very high speeds in a circular path called as orbit. Then what he thought? There must be the electrons which are rotating beside the nucleus. So the electrons and the nucleus are held together by certain attractive force. Okay, so therefore attractive electrostatic force of attraction was present between the nucleus which is present at the center and the electrons which are rotating outside. So this is similar to that of our universe. Now in our universe, in our solar system, it is seen that in the center there is the sun. So if sun is present over here, so there are certain planets which are rotating here. So he thought that these planets, so if this is the planets, so these planets are rotating beside the sun from several years. Exactly, this is in the macro level, but in the atom also something like this only must have happened in a micro level. So our sun seems to be like a nucleus, and our planets are like the electrons. So as you know, sun is very huge and it is dense. We cannot look at that sun directly. So but it is far off and hence it seems to be smaller. In the same way, the sun was considered the nucleus, and these planets were considered as what? These are the electron. So as you know that the planets are rotating around the sun, in the same way In the atom, what is happening? Electron is going on rotating. So these paths were called as what? It was called as orbit. But you also know that these planets, they are rotating around the sun, but they are also rotating around themselves also. This point is to be noted. So in this way, the Rutherford's model was proposed, in which nucleus, a very small nucleus but dense, is present at the center, and the electrons are moving in an fixed path called as the orbit. Hence, Rutherford model helped to construct the structure of atom, but still there was certain drawback for the Rutherford's model. Now, what was the drawback? Rutherford's model doesn't suggest specific radii for the orbit of the electron. Now, he told that it is rotating around the nucleus, but what is the fixed radius for that orbit was not mentioned. Then, the model also failed to explain regarding the emission and the absorption spectra of the elements which were studied further. Since he could not explain regarding the spectra, this theory could not exist for a longer time. Then came into existence the next theory, which was given by Bohr. So Bohr's model of an atom, we will be studying it very soon. So before that, we have something called as some terms which are involved in this chapter, which you have already studied in your school days. So like, for example, atomic number. Atomic number is represented by Z. So it indicates the number of protons in the nucleus. Then neutrons, the number of protons and neutrons together, they are called as what? Nucleons. And what is the mass number? Mass number is the sum of protons plus neutrons. That means total number of nucleons together is called as the mass number. See, atomic number is number of protons and mass number is what? Number of protons plus neutrons together. What is isobar? Isobar are the atoms with same mass number but different atomic number. So mass number A should be same, means number of nucleons should be same, but atomic number is different. They are called as the isobar. So for example, C, which is having atomic number 6 and mass number 14, nitrogen atomic number 7 and mass number 14. So together they form isobar, means they belong to different elements, means they have different atomic number but their mass number is same. So these are isobar. Then how is it different from isotope? Isotope means the atoms which are with same atomic number but different mass number. They are of the same element. Example, hydrogen, isotopes of hydrogen. So in the isotopes of hydrogen, we have 1H1, 2D1, 3T1. That is, this is called as protium, this is called as deuterium, this is called as tritium. All the three belong to hydrogen itself. Only thing, the number of neutrons are going to vary. So here you will have 1, here you have 2 and here you have 3. So totally together, so neutron plus proton, that means nucleon. So this indicates the number of nucleons present. So therefore they have the same mass, they have the same atomic number but they have different mass number. These are called as the isotope. For example, also you have carbon. So carbon all have atomic number 6 but the mass number you can see it is 13, 12, 13, 14. So their number of nucleons are going to vary. So in this way we have the certain important definitions to be known, like the atomic number, atomic mass or the mass number, nucleons, isobar, isotopes. So now after knowing the atomic number, mass number, how to represent these in the form of a symbol. So now suppose if you are given atomic number, suppose Z, that is Z is equal to, let me say 17, means atomic number is 17. You have to represent it in terms of symbol. And its mass number A is equal to 35. Now atomic number 17 is which element? It is chlorine. So I shall write the symbol of the chlorine. So symbolically, how you are going to represent this one? Atomic number 17 is chlorine, so I wrote Cl. So this atomic number is represented at the below portion. So we write it here as 17, and the mass number is written as 35 at the top. So for a given element X, you have to write the atomic number at the bottom and you have to write the mass number at the top. So mass number means what? Total number of neutrons plus protons together. Z indicates what? Number of electrons. So you are supposed to write it symbolically like this way. Now, suppose if you know the atomic number and the mass number, so you should be able to find out the number of electrons in that one. Now, for example, suppose if you want to find the number of neutrons or the electrons or the protons, we should be able to find it by knowing the two, the third can be obtained. So, suppose if at all you are given with atomic number as 12. So, atomic number 6, that is, let me say it is carbon. Now, atomic number is 6, so this is carbon. Let me say the isotope is nothing but 12. Now, out of this one, 6 indicates what? Number of electrons or number of protons which are equal, and the mass number is given as 12. Now, if I want to identify the number of neutrons, so what are the number of neutrons? So as you know that number of electrons and number of protons are same in a neutral atom. So atomic number 6, that is number of protons, is equal to number of electrons, right? So these number are same. Now suppose if I want to find the number of neutron, I have the mass number. So mass number is 12, which is the sum of what? Proton plus neutron. So proton plus neutron is equal to 12 minus the number of electrons is equal to number of protons. Suppose if I remove it, 6. So what is left out? It is 6. So the number of neutrons in this one is how much? It is 6. Suppose I write it as 13C and 6. That is one more isotope of carbon. How many neutrons are present in this one? Now how to find out? You have the mass number, that is 13, which is the sum of proton plus neutron, minus the number of the electron or number of proton which are equal. So if you take out this 6, so totally how much you are going to get? You are going to get 7. So in this one, what are the number of neutron? There are 7 neutrons in this. So in this way, we should be able to predict the number of the neutrons. Now, after knowing all these terms, so here after finding the different models like the Thompson's model of the atom, after the discovery of the subatomic particles, the next model which was proposed was Bohr's model of an atom. So Bohr's model of the atom could explain major properties like the dual nature of the electromagnetic radiation and the atomic spectra, which was not explained by Rutherford. So this led for the development of the Bohr's model of the atom. So remaining things we shall see it in the other video. Thank you.